Today on IODP Expedition 318, Wilkes Land. Exploring the history of Antarctica.
This is a drill. This is a drill. All personnel report to your lifeboat stations.
Good morning, world. Here we are on the far edge of the planet, looking over Antarctica. And all of that with the sad news that we, as Dutchmen, have failed again on the Olympics.
Everybody's got a hard hat that looks kind of like a dome, but mine's a cowboy hat. Once in a while we get out on those icebergs and we ride them and we buck and we gotta have the image, you know?
Where are the penguins?
The penguins, I've sent them to Che. They better behave.
What are you going to tell about?
I'm going to tell about diatoms and how they can show us about sea ice history. I find it exciting that we can say something about the history of our planet from fossils and sediments. I think that's important for us to understand how the cryospheric system operated in the past to be able to help predict global climate in the future.
Are these gone in 30 seconds?
I wish they were. Looks like we're kind of maneuvering right now. Trying to see if we can find a little hole to get through so we can get down to some greenhouse world sediments.
The job.
And my role on the ship is as the coordinator for the paleontology team. Today we're looking at microscope slides, and we process material in the paleontology lab and extract information from the microfossils. So it's mostly looking at ages. We also look at the fossil species to determine the environment that they were deposited in, whether it was a sea ice environment or an open water environment, whether it was hot or cold. So one of the missions we have on the Wilkes Land expedition is to discover the nature and the timing of first ice along the Wilkes Land margin, and whether it was glacial ice which first arrived here or sea ice. And we're hoping to validate a climate model such as this, which predicts that sea ice occurred soon after grounded ice sheets occurred along this margin.
I'm great, how are you?
I'm good. Some icebergs to see, finally. This is great. It's important to differentiate between land-based ice and sea ice, because land-based ice can affect sea level, and this is important for society today. So we need to understand how the ice sheets have waxed and waned in the past, maybe in response to CO2 fluctuations. And sea ice doesn't affect sea level changes, but it does affect ocean atmospheric exchanges, and that can affect the global energy budget, for example, through the ice albedo effect, and it can affect our weather patterns. So we say ice is ice, but it's important to differentiate between land-based ice and sea ice.
Today on Penguin TV, ocean drilling for kids.
What do you do on the ship?
I'm a technician working in the chemistry lab.
I
told you guys.
What's that, chemicals? Yeah, chemicals. Yeah, we analyze different kind of chemical elements and components in the core.
Chemicals?
Yeah.
Are they safe?
Well, some chemicals are dangerous. That's why you need to wear personal protection equipment. Do you know what that is?
Yeah, we did that on the reef floor. We wore our hard hats and our glasses.
Che, yes.
Are chemicals in fish?
Yes, absolutely, yeah. We also, you eat them, yeah. We also measure carbonates. And carbonates is everybody. In the fish, in the sediments, yeah, in you.
Fish. Yes.
You know what fish eat?
Diatoms.
All right. Do you know what diatom is made of?
No.
It's silicate.
Silly.
Yeah, we measure silicate in the cores.
You work on that? How do you analyze it?
Yeah.
It's complicated.
It's complicated.
Yeah, we have 10 major instruments in the chemistry lab.
10?
10. Yeah, we also measure carbonates.
Carbon? You measure carbon?
Yeah. And you know what carbon also can tell us?
No. What?
Climate change. Are you climate change skeptics?
No.
We want cold.
We want cold.
You know what? The co-chiefs know everything there should know about climate change. So you guys should go talk to them for sure.
Who's that? The co-chief.
Co-chiefs, yes.
And they love to talk to penguins too.
Yeah. And fish.
We want fish. We want fish.
The journey.
How you doing, John?
Good, but I can't have you there in this shot.
I'm ready for new core.
I'm absolutely ready for core.
little butterflies in the stomach.
I'm looking forward to the next couple of drill sites. So we've had a little bit of trouble getting into one of our aimed sites. There's been a little bit too much sea ice and icebergs around, but we've managed to achieve most of what we wanted to do. So what we get now in the next couple of weeks will be a bonus.
Nice score, John.
Yeah, very nice car.
Yes, I think so.
The science.
Glaciation on Antarctica occurred with isolated ice caps and elevated places on Antarctica, and at some point they coalesce very rapidly, and at a certain threshold of 2 to 3 times the pre-industrial CO2, then it goes really quickly, and Antarctica is glaciated within a few 100,000 years. We use these climate models as a first stage prediction, and what we find in sediment drill cores on the Wilkes land expedition helps feed back into these models and refine them. So, for example, the microfossil assemblages that we find and the lithological sequences feed back into climate models to make better predictions. One of the aims of this expedition is to validate this model. And diatoms are one of the ways we can do this, because they trace the edge of the sea ice, and they can also tell you something about sea ice seasonality or whether it was permanent. So we're now in the Antarctic, but it's also important to look to the Northern Hemisphere for a bipolar perspective on the cryospheric evolution of the planet. We know already that sea ice formed in the Arctic about 16 million years before the ice sheet in Antarctica formed, but we don't have enough cores of the right age to be able to say if there was a bipolar connection between Arctic sea ice and Antarctica. So that's why we're here.
Ocean man, take me by the hand, lead me to the land that you understand.
I was amazed when I first saw the ship in Wellington. I sailed on the JR 10 years ago on another expedition. She was wonderful then, and we had a really good time and we achieved our aims, but with the refit, the state-of-the-art equipment here is unbelievable, and everything works like clockwork in the labs. They've done a really good job on the ship, actually, so really impressed, and everybody's really impressed.
Today on Gone in 30 Seconds with Stephen Picard.
Very good.
The ocean drilling program has been the most successful terrestrial-based organization the world has ever seen. We have over 20 countries working together, almost like a futuristic utopia where everyone, whether it's from China or Japan, Europe, wherever, we're all working together in mutual cooperation to learn. It's almost like Star Trek, in fact. We don't have to worry about national pride and egos. We're all just trying to discover and learn and having that excitement of pure discovery.